Here's how almost everyone pictures an AI agent, a while loop. Call the language model. Check if it's done. If not, run whatever it asked for, loop back, and repeat until it stops. And honestly, for a quick demo, that works. But the moment you try to ship it, to make it reliable, debuggable, something you can actually trust, that little loop starts to crack. Watch it shake. A while loop around an LLM is the wrong shape for a real agent. So here's the idea that fixes it. And it's the whole video. A real agent isn't a hidden loop. It's a graph. Nodes that do the work. Edges that decide what happens next. And one shared state that flows through all of it. Watch the graph build, piece by piece. There's a start, an LLM node that acts as the brain, a router that makes decisions, a tools node, and an end. This way of building agents has a name. LangGraph, from the team behind LangChain. By the end, you'll never look at an agent as a while loop again. First, let's be honest about why the naive loop breaks. A bare while loop fails you in 4 ways, and they're all about control. It's opaque. You have no real idea what it's doing inside. It's hard to steer. There's no clean place to pause or gate a single step. It's hard to debug. No trace, no replay, no way to ask what happened at step 7. And it has no memory of where it is. It just churns forward. It runs until it stops. And when it goes wrong, you're left staring at a wall of text with no way. Let me show you the moment it derails. Step 7. The agent calls a tool to get a price. Step 8. That tool errors out. And now watch. Step 9. The loop just calls it again. Step 10. Again. It's burning tokens. Going nowhere. Stuck in a corner it can't see. And here's the painful part. You can't pause it. You can't inspect it. And you certainly can't resume it from step 6. The control you need simply isn't there. We need a better shape. That better shape is a graph. Let's build it from 2 pieces. Piece 1, nodes. And a node is just a function. It takes the current state, does exactly one thing. Call the model, run a tool, transform a value, and returns an update. That's it. Here, the call model node takes the state and hands back the model's reply. The LLM node, the brain of the whole thing, looks special, but structurally it's piece 2, edges. If nodes are the work, edges are the wiring. An edge simply says, after this node, go to that one. Run the LLM, then go to the router. You add an edge from start to the LLM node, and you've declared the order the work happens in, right out in the open. So think of it like this. Nodes are the verbs, edges are the arrows. Put them together, and you've already got the skeleton of an agent. Now, the thing that ties every node together, the state. Here's what makes a graph an agent and not just a flowchart. One shared state flowing through it. Watch it fill in. The state holds the messages, the conversation so far, a scratchpad, the agent's own thinking, and results, whatever the tools returned. It's a single typed object, usually a TypedDict, that every node reads from and writes to. No hidden globals, no tangled side effects. One clear source of truth that travels down the edges with the work. And crucially, each node updates that state as it goes. The LLM node appends the model's reply to messages. The tools node appends what the tool returned to results. Then the next LLM node reads all of it, the full accumulated picture, and decides what to do next. Notice it only. Here's the part that turns a pipeline into an agent. Choices. Look at the router in the middle of the graph. The edges coming out of it are dashed, and that's deliberate. These are conditional edges. From the router, the next node isn't fixed in advance. A small function looks at the state and picks where to go. If the model asks to call a tool, head to the tools node. If the answer is ready, head to end. That branching, choosing the path based on what actually happened, is exactly what makes this thing an agent rather than a straight line. And the routing logic is refreshingly simple. A root function reads the state, really, just the last message, and returns the name of the next node. Did the model request a tool call? Return tools. Otherwise, return end, continue, call a tool, or finish. 3 doors, and the state decides which one opens. That's the entire decision-making core of the agent. In a handful of lines you can read, test, and trust. Now we close the loop, on purpose this time, and let a human in. Follow the edge from the tools node back up to the LLM. And because the state is explicit, you can do something the while loop never could: stop and resume. When the agent proposes something risky, spending money, sending an email, deleting a file, the graph can interrupt and wait. Checkpointing saves the entire state to durable storage at every step. So a human can approve, and the agent resumes from exactly where it paused. The same mechanism means that if the process crashes, you don't start over. You continue. That's persistence and human oversight, built right into the shape. So step back. Why does drawing the graph win? 4 reasons, and they're exactly the things the while loop took away. It's durable, checkpointed so you can resume anytime. It's controllable. You can gate a step, branch on a condition, interrupt for a human. It's observable. You can trace every node and every edge the request took. And it's testable. Each node is just a function, so you can check it on its own. Everything the loop hid, the graph makes explicit. And explicit is what you can actually ship. Let's trace one real request through the whole graph. Someone asks, "What's the weather in Tokyo?" Watch the active node light up as we go. The question enters as state at start and flows to the LLM. The model thinks, "I need live data." So the router takes the conditional edge to the tools node. The tool fetches the weather, and the result loops back into the state up to the LLM. Now, with the fact in hand, the model can answer. The router sends it to end. One request, every step lit, fully traced from question to answer. One last layer turns a clever demo into something you'd actually ship, making the graph trace itself, retry when a step fails, and resume right where it stopped. Now watch what happens when a tool fails, because in the real world, they do. The router takes the conditional edge to the tools node, and the call to the price service times out. In a bare while loop, that's where things spiral. It just calls the same broken tool again and again. But here, the failure is written into the state as a plain fact. The edge carries it back. The model sees the error, and the router gets to choose what comes next. So it routes to a retry, this time with a backoff. And if the tool is still down, it routes to a fallback node instead of crashing. That's the whole point of a graph over a straight chain. An error becomes one more thing the agent can read and route around on purpose. Let me make the checkpointing concrete, because it's easy to underrate. As the agent works, the same state object fills in the messages, the scratchpad, the results, and at every step, that whole object is saved to durable storage. So this run isn't a fleeting thing happening inside a function call. It's a record you can hold. You can pause it midway and inspect exactly what the agent knows. You can hand it to a human, get a decision, and resume from that precise point. And if the process crashes, the state is already on disk, so you pick up where you left off instead of starting over. Contrast that with a stateless chain, which forgets everything the instant it returns. Persistence is what turns a one-shot call into a process you can actually operate. Let's put it all together with one more trace. A research agent this time. It starts at the LLM, reasoning about what it still needs to know. The router decides the evidence is thin, so it takes the conditional edge to the tools node and retrieves, searching the docs, dropping the results into the state. Back up to the model, which now reads that evidence and drafts an answer. But watch the decision again. One fact looks shaky, so the router loops back and retrieves a second time, gathering more support before it commits. Only when the answer is well grounded does the router send it to end. Retrieve, reason, decide, act. Round the cycle as many times as the question demands. Same 5 nodes you've watched all along, now solving a genuinely hard task. So here's the whole thing in one breath. An agent is nodes that do work, edges that decide. So the next time someone calls an agent, a while loop calling an LLM until it stops, you'll know the better picture. It's a graph, deliberate, durable, and something you can see, steer, and resume. Stop writing while loops. Draw the graph. Subscribe for more such intuitive videos.